Let's see the question 10th, which is the last question of this assignment, which is about K nearest neighbors, KNN. Uh, K nearest neighbors is a classification algorithm that predicts the class of a new point based on its K nearest neighbors in the training data. It's called a lazy learning algorithm because there is no explicit training base. The algorithm simply stores all training data. It's instance based, meaning it stores every individual training example. Predictions are distance based using either Euclidean distance, the straight line distance, or Manhattan distance. The grid based system, the final prediction comes from a majority vote among the k neighbors. If we have a k equals 3 and two neighbors are class A and one is class B, the prediction is class A. So what is KNN? The KNN algorithm follows four simple steps. Step 1, store training data. Unlike other algorithms, KNN doesn't train a model. It just stores all training instances. Step 2, calculate distances. When we get a new point to classify, we calculate the distance from this new point to a training point. Step 3, find k nearest. We sort all distances and select the k closest neighbors, the trailing points nearest to our new point. Step 4, predict class. Finally, we look at the classes of these k neighbors and take a majority vote. Which class appears most frequently among the k neighbors becomes our prediction. Choosing k value. How we choose k value? The choice of k is crucial for model performance. With small k, the small k like k equals 1, the model is very sensitive to noise. Even a single outlier can influence the prediction. It can overfit learning noise rather than the true patterns. It follows the data very closely. This is good for finding local patterns but risky. With large k like k equals the total number of data points n, the model creates a smoother decision boundary, but it can underfit. Missing important local patterns is based on global patterns which loses detail. Typical values in practice on k equals 3, k equals 5, or k equals 7, which typically choose odd values to avoid ties when voting. The base k value depends on your specific data and problem and often requires experimentation. Let's see the KNN. We have seen the choosing KNN. Let's see the KNN advantages and disadvantages. So the KNN has several advantages. It's simple to understand. The concept is intuitive. There's no training needed. You just store the data. It works for both regression and classification tasks. It's non-parametric, meaning it doesn't assume any particular distribution. However, KNN has significant disadvantages. Prediction is slow because you must compute distances to all training points. It's memory intensive. You store every training instance. It's sensitive to irrelevant features. Noisy features can mislead distance calculation, and it suffers from the curse of dimensionality. Performance degrades as the number of features increases because data becomes sparse in high dimensional spaces. This brought us to the summary of our video. To summarize, part 5, one-hot encoding converts categorical variables into binary format for machine learning. It prevents artificial ordinal relationships and properly represents categories. K nearest neighbors is an instant-based lazy learning algorithm. It stores all training data without explicit training. It predicts it predicts by finding k nearest neighbors and taking a majority vote. Distance matrix can be Euclidean or Manhattan. The k value is critical. Small k rises overfitting, large k rises underfitting. KNN is simple but has computational trade-offs. It's fast for training but slow for prediction and memory intensive for large data sets. So that concludes part 5 and the entire data science assignment. You now have comprehensive coverage of fundamental machine learning concepts from supervised and unsupervised learning to data validation to evaluation to feature engineering and model complexity to regression algorithms and finally to data encoding and instance based learning. So we have completed our all four parts And this is the end to our data science series. Thank you for watching my video and subscribe to my channel.